Lesson 3.11, Absolute Value Functions. In a previous lesson, we've discussed absolute value, and the absolute value is the distance from zero on a number line, and therefore it's always positive. For example, if we have the absolute value of 4 or the absolute value of negative 4, 4 is 4 units from zero on the number line, so the absolute value of 4 is 4, and the absolute value of negative 4 is also 4. That way, we know that if the absolute value of x is 4, x could be either 4 or negative 4, and we can use this information to graph the absolute value of a function. Okay, in order to graph our absolute value functions, one of the easiest ways is to use a t-table. So if we want to graph the function y is equal to the absolute value of x minus 1, we'll start plugging in values of x. So if I plug in x for 0 for x, I get the absolute value of 0 minus 1, which is the absolute value of negative 1, which is 1. If I plug in 1 for x, I get the absolute value of 0, which is 0. If I plug in 2 for x, I get the absolute value of 1, which is 1. If I plug in 3 for x, I get the absolute value of 2, which is 2. And as you can see, I have a pattern. It goes 1, 0, 1, 2. If I go to negative 1, I get the absolute value of negative 2, which is also 2. Now, absolute value graphs, when we have a linear equation, so for example, y equals mx plus b, we get a straight line. And when we have a quadratic, we'll get what's called a parabola, which is a curve. An absolute value function is going to graph as a v. So in order to graph this, I'm going to plug in my points 0, 1, 1, 0, 2, 1, 3, 2, and negative 1, 2, and you can see we get a V pattern. We want to make sure we have a nice point on that, a nice V. So this is the graph of the function y is equal to the absolute value of x minus 1. So we can try another one. This time we're going to graph y is equal to negative the absolute value of x minus 2. And the reason I chose this example is because that negative out front is actually going to change our graph. So I'll make my t-chart, and when I plug in 0, I'm going to get y is equal to negative the absolute value of 0 minus 2, so that's negative the absolute value of negative 2. The absolute value of negative 2 is positive. This negative out front will make it negative. So I'll get negative 2. If I plug in 1, I get negative, negative 1. Now this is not the same as when we had a negative with a parenthesis. When we have a parenthesis, we can distribute in, and that gives us a positive 1. When we have a negative outside of an absolute value, think of this as a wall. We can't cross it. So what we have is this negative that hangs out, and then the absolute value of negative 1 is 1, and that gives us a negative 1. So this is going to be negative 1, not positive 1. So 1 gave us a negative 1. The absolute value of 0 is 0, and there's no such thing as negative 0, so this is just 0. Okay, absolute value of 2 is 2, and the negative out front makes it a negative 2. oh, sorry, that should have been 3 minus 2. That should have been a negative 1. Apologize for that. So then if I use 4, I get negative 4 minus 2, so that's negative the absolute value of 2, which is negative 2. So I have points. When you see that you've changed direction, so I have negative 2, negative 1, 0, negative 1, negative 2. Because we're looking for that V shape, like this, you can't see that, like that, we're going to have to look for that place where we change direction. So at 0, I'm at negative 2. At 1, I'm at negative 1. At 2, I'm 0. 3, negative 1. And 4, negative 2. And you'll notice I still have a V, but this time it's facing downward. And the reason that that occurs, that downward instead of upward, is because I have a negative out front. So we've done some of the basics of, we've done some basic graphs, but let's talk about if I have y equals the absolute value of x. This is the most basic absolute value function we can have. And what we'll have is a graph that looks exactly like this. And this is known as the parent function. Okay, and what this parent function is it is the basic graph of an absolute value function. All other absolute value graphs are based upon this parent function. So if we look at some of the more basic changes, if I make a negative absolute value of x, this negative out front flips my graph. So instead of being a V that opens upwards, it will be a V that opens downwards. Okay, so negative outside flips the V. Okay, there are other changes that can occur. We had in our original graphs that we just graphed right now, we had a number being added or subtracted. If I add a number, I'm going to shift. So if I have x plus a number, I shift that many spaces to the left. If I have y is equal to the absolute value of x minus a number, I'm going to shift that many spaces to the right. Right. Okay, and that's if the number is added or subtracted inside the absolute value. Now we can have other scenarios too. We can have x, absolute value of x with a number added on the end, and this will shift that many spaces up. And if we have y is equal to the absolute value of x minus a number, we will shift that many spaces down. If we multiply some number times the absolute value of x, we are going to shrink or stretch the V of the graph. And that will depend on what number is being multiplied. And that's our basic changes that can occur. So if you learn the patterns, sometimes you don't have to do a t-table to graph them. I like to usually generally do a t-table just because I feel like it makes things more accurate and I know that I'm getting the graph in the right place. But here, let's do an example of a negative absolute value that has 1 subtracted from it. Okay, now because it's negative, I know it's going to be flipped. And because it's being 1 subtracted from it, I know it's going to move down 1 and flip over. So I know it'll go that way, but we can go ahead and make a t-chart just to be safe. If x is 0, y will be negative 1. If x is 1, I have negative of 1. So negative 1 minus 1, so that gives me a negative 2. If x is negative 1, I have a negative of 1, so that's negative 1 minus 1 is negative 2. If x is 2, I'm going to have negative 3. If x is negative 2, I'll also have negative 3. So I get this point pattern, and as you can see, it's the same shape, but flipped over and moved down 1. If we combine multiple changes or transformations to the graph. So for example, if I graph y is equal to 2 times the absolute value of 2x plus 2 plus 4. That's a lot going on. So on these kind of graphs, I do like to go ahead and make the t-table. Now I know it's going to be pointing upward because it's got a positive 2 in front of it and there's no negative out here. So if I start plugging in numbers, if I plug in 0, I get 0 plus 2, that's 2, times 2 is 4, plus 4, that's 8. If I plug in 1, I have 2 plus 2 is 4, times 2 is 8, plus 4 is 12. If I plug in negative 1, I have negative 2 plus 2 is 0, times 2 is 0, plus 4 is 4. So you can see I don't actually have my pattern yet. If I start plugging these points though, 0 is 8. If I call each of these 2, so I'll do 2, 4, 6, 8, 10, 12, 14, 16. So 0 is 8, so 2, 4, 6, 8. 1 is 12, 8, 10, 12. Negative 1 is 4. Just connecting these dots, I can see that I need to keep going this direction to get my V. Because it's not negative, so I don't need to come down like this. I need to go somehow come this way. So I'm going to keep going negative. Negative 2 gives me negative 4. Plus 2 is negative 2. Absolute value of negative 2 is positive 2. Times 2 is 4. Plus 4 is 8. So negative 2 gives me 8. Negative 3 gives me negative 6. Plus 2, which is negative 4. The absolute value of which is 4. Times 2 is 8. Plus 4 is 12. Now I have my shape. And so as you can see, this 2 out front made it skinnier, and we moved up 4, and we moved back as well. So that's why the t-table is nice, because I didn't have to try to figure out all the changes that were occurring. I can just find my points. And that is how you graph an absolute value function.